This is Swathiramya, Assistant Professor, AIDS Department, Hindusthan Institute of Technology. Welcome to my video. In this video, we are going to talk about the basics of Java programming. Okay, let us move towards the object-oriented programming principles. So, let me first list out the concepts of object-oriented principle first. It starts with a class, object, abstraction, encapsulation, inheritance, polymorphism. Let me give you the one-line definition. What is class and object, all these things, okay? Then we'll get into the deeper with a real-time example so that you can have a better idea. First of all, what is class? Class is a blueprint or a template of a real-time things, okay? Object. Object is an actual instance created from the class. So, without a class, object will not be existed. Only if you have a class, you will have the object for that particular class. Abstraction means focusing on essential information and hiding unnecessary implementation details to the client or the user. Encapsulation means combining data and methods together and protecting the data. Inheritance allows one class to acquire the properties and behavior from another class. And the polymorphism means one interfaces or a method can take a different forms. This I just told you only one line definition or one line concepts of object-oriented principle. Let's get deeper into these concepts and I'll explain with a real-time example too. Okay, let's take the real-time example as a car. Okay, so let us understand the concept of the class using a very simple real-time example, a car. Imagine that you want to create a program for a car. Okay, before creating an individual car, we need to design. Suppose you want to design a car, suppose you want to manufacture a car. Okay, think like in that way. So before manufacturing a car, we need a design or a blueprint for that car. The blueprint can describe the property of the car that we are going to manufacture. That is, it will describe you how the car we want to manufacture. That's color of the car, model of the car, speed of the, how the speed should be, and the fuel type. All the specification should be there in a design or a blueprint of the car should be manufactured. That is like creating the class. So the class will give you the design or the blueprint of the car that we are going to manufacture. So it can also describe the behavior. The class, which is not only describe the property or a property of the car, it also going to describe the behavior of the car. For example, it has to start, it has to stop, it has to, when we press the brake, it has to stop the car. When we press the accelerator, it has to move forward. When we put the reverse gear, it has to go backward. So these all behavior things also the class needs to describe. So first thing, it will give you the property of the car that we are going to manufacture. That is the blueprint or design of the car. Next thing, the behavior of the car. It is also going to tell what kind of the behavior the car has to going to do with it. Okay, this is the class. So the class will tell you the properties of the real-time object that we are real-time things that we are going to develop, and also it will give you the behavior of that particular things that it is going to do. Okay, so that is why it is called as a blueprint of the class. Class is a blueprint. Okay, once we have a class, we can create multiple objects from that. For example, once we have a design or blueprint of particular car, using this blueprint, we can able to manufacture n number of cars, right? Once we have a blueprint of that particular car, design, we can manufacture n number of cars. So once we have a class which has the properties and behavior of that particular car, with this class we can able to create n number of objects, right? Now you understand what is the relation between the class and the object. Class is a design or a blueprint of some particular thing. It will give you the properties and also behavior of that particular things. So once you have a design, you can manufacture n number of the product, same product with that property with that property and the behavior, that is objects. So you can have the one class and you can have a number of objects created with the class, right? So now you understand what is the relation between the class and the object. For example, we can create one car object representing a red car and the another car object representing a blue car. For example, we have created the class car. We have created the two objects for the class. Okay, so one car will be on red color, another car will be on a blue color, another car will be in a pink color too. So for different colors we can use different object has been created. Both the objects can belongs to same car class, but they can have the different properties. They can have the different values. So the basic relationship between the class and object, this is how it works. Okay, so now let's define a class more formally. A class is a blueprint or a template used to create an object. A class will define you the properties, behavior, and its object will have these properties and behavior. The objects that we create using this class will have the properties and behavior that we defined inside the class. In Java, properties are generally represented using variables, while the behaviors are represented using methods that we call it as a functions. Method is nothing but it is a functions. Okay, so the properties of the car, for example, the properties of the car will be defined with the help of variable declaration, and the behavior of the car will be declared with the help of the functions and the methods inside the class car. Okay, suppose we create the class, where we create the class name student. The student class may contain the variable names such as name, register number, department, year of study. It may also contain functions or methods like display the details, display their marks, display their CGP, display their grade. All those things will be come under the behavior or the functions inside the class students. So let's relate the data and the operations together into the single unit. In simple words, remember that class means a blueprint. It describes what an object should contain and what it should be able to do. Class will describe you the properties of the particular object, and it will also tell you what all the functions it can able to do. These all things will be described inside the class. So next we will move to the second important concepts of oops, that was an object. As I told you before, what is the exact relationship between the class and object? Now object is nothing but it's an instance of a class. So if the class is a blueprint, then the object is actually the entity created using the blueprint, right? For example, if a student in our class, then we can create individual student object from that class. We have created a class name student, and we will describe what all the details of the students in the variable name and their functions, what all the behavior or the functions in the method as a method inside the class. So we can create n number of objects for each student. For example, for register number 1, we can create the object 1. Register number 2, we can create the object 2. So the object 1 will have the details of the register number 1. Object 2 will have the details of the register number 2. This is how we can organize that thing, and large number of data can be organized in this way. Each object can have its own data. Object generally has two important characteristics. As I told, one is a state and another one is a behavior. State represents the properties, that is data of the object. In our example, the class student, the data will be the register number, name of the student, and the year of the study department. All those things will come under the state or a data of the student. Behavior will represent the actions that the objects can perform. For example, total marks, CGPA, functions like CGPA or grade points. All those things will come under the behavior or the functions. Okay. So the student objects may have a name. Student objects may have the details like name, register number as it states, while the methods such as display the details and its marks, cumulative marks, CGPA and grade points, all those things will come under functions. So class is a blueprint, object is the instance of the actual class. Okay, this is how the class and object works here. So next important concepts of object oriented programming is abstraction. So now let's try to understand what is abstraction. Abstraction means showing the relevant information and hiding the unnecessary implementation details. A simple way to remember abstraction is what it does rather than how it does. It will tell you what it will do. It will not tell you how it is done. Right? This is a simple way to understand what is abstraction. For example, when we go for the ATM, we know how to insert the card and how to enter the PIN and select the options. We can withdraw the money, but we do not know all the internal processing that happens inside the banking system when we click withdrawal, when we insert the card, what all the operations that has been done, that has been happening inside the ATM machine. We doesn't know about it. So we know only what it does. We doesn't know what internally how internally the operation has been done. This concept is called abstraction. So the complex implementation will be hidden from the user. We don't need to know all the internal processing that happens inside every process that happens inside the banking system. Similarly, in the programming also, the abstraction allows us to expose only the necessary functionality while hiding this internal things is most important in the programming also. This makes the programmer easier to use and understand the things. Okay. Next concepts will be encapsulation. Encapsulation means combining the data and the method that operates on that data into a single unit. Usually we call it as a class. We will combine the data and the method that operates on the data into the single unit. That is, inside the class we have the data, that is the properties of something, and the behavior of that some objects, right? So this is a class. So that is what the encapsulation also. We combine the data and the methods, and that operates together into the single unit. The single unit is called as a class. So it also provides the way for the protection of data from unauthorized access. In Java, access modifier, such as we have an access modifier in Java which helps to protect the data. That is, every data cannot be used by every user. Only particular data can be used by particular user, and particular data will be in a private mode that cannot be used by everyone. So we can use this access specifier to make it as a private data or public data. We have two modes called private and public. Suppose a bank account has a balance, user, the customer could not able to access the bank account. We should not able to edit our bank account amount, right? So it will be in the private mode. Only authorized person can able to edit the amount. Total amount in the bank account. So this kind of property which helps us to do this purpose. So we can keep the balance as a private one and provide the appropriate public methods to access or modify it. So this concept is often explained using two terms, that is data hiding and data protection. So when you hear the encapsulation, the definition for encapsulation is very simple. Wrapping up of the data and the methods together and controlling the access of the data. It will combine the data, that is variables, and the methods together into the single unit, that we call it as a class, and we control the access of these data and the functions to be accessed by everyone. This controlling access will give you the feature called protecting the data from every user. So the next concept will be the inheritance. So inheritance is a mechanism by which one class can acquire the properties and the behavior of the another class. The existing class is commonly called the parent or a superclass, and the new class is called the child or subclass. Okay. So for example, consider a class called a vehicle. A car and a bike can be created as a subclass of the vehicle. A common properties and the mechanism of the vehicle can be placed in the vehicle class. The car and the bike class can be reused those functions in the vehicles. The major advantage of using the inheritance is a code reusability. So instead of writing the same code repeatedly, we can place the common functionality in the parent class and reuse it in the child class. So this helps to reduce the duplication and makes the program easier to maintain. As I told you, it's very clear that we can have one parent class. In the one parent class, we can declare our functions, necessary functions, and we can import or inherit these parent class to their subclass or child classes. For example, for the vehicle, parent class can be the vehicle, and the subclass or a child class can be a car and the bike. For both car and bike, we will have the similar functions like start and stop. So these similar functions can be imported from the parent class vehicle, but they have some other unique features also. For example, acceleration. For example, you will have the functions like gear, all those things in the car, but in a bike we have a different kind of functionality. So unique functions can be written uniquely. Unique functions can be written separately in their own child classes. Common functions like starting, stopping, fuel level, all those things functions can be imported from the parent class vehicle. By this way, we can reuse the code once we have been written in the parent class, and we can reuse the code whenever we need it in the child class. This is how the inheritance works. So we will move to the next concept called the polymorphism. The word polymorphism comes from the two words, that is, it is actually a poly means many, morph means form. So it is taking many forms. Polymorphism means many forms. So polymorphism literally means taking many forms. In Java, polymorphism means that the same method or the interfaces can have different behavior depending on the situation. For example, suppose we have a method called draw. A circle object may use this draw method to draw the circle. Rectangle object may use the same draw method to draw a rectangle. And same thing, you can have the same function which literally works different in the different places or situation. The method name is the same, but the behavior can be differs depend on the situation or depends on the object we call for. So polymorphism is a very powerful concept because it allows us to write flexible and reusable programs. So these are the basic concepts of OOPS and the basic features of the Java. So